Question 5, a gas cylinder of air at room temperature of 27 degrees Celsius and a pressure of 200,000 pascals is accidentally placed in a fire at 130 degrees Celsius. The cylinder's volume increases by 1%. Explain using the particle model why the pressure in the cylinder increases. So we know that the temperature of the gas increases, so the particles travel faster, hitting the walls harder and more often. We could say the slight increase in volume does not affect this significantly. So the pressure increases. Calculate the new pressure of the gas. So we're going to go back to using the combined gas law. P1 V1 over T1 is equal to P2 V2 over T2. So we've got more quantities here and we've got some in the wrong units. So we might write them all out a bit more carefully. So P1, the initial pressure is 200,000 pascals. V1, the initial volume. Well, we don't know, but we do know that it says it goes up by 1%. So I'm going to write this down as 1.00. And we can use a relative quantity for V2 when we come to it. T1 is, dashes, let's put equals in. T1 is 27 degrees Celsius, but we need to convert this into Kelvin. So this is 300 Kelvin. P2 is the thing that we're trying to find, so we don't know that value. V2 is the final volume, and we know it gets 1% bigger. So here, if I've got 1% bigger, I can just write this in as 1.01. Obviously, I could use 100 and 101. Could use any pair of numbers as long as one is 1% bigger than the other. T2 is its final temperature, 130 degrees Celsius plus 273. So that takes us to 403, isn't it? 403 Kelvin. So we want to find the new pressure. So P2, rearranging this equation, we get P1 V1 T2 over T1 V2. So always worth double checking our rearrangement whenever we come to rearrange this equation, because the subscripts are so important. I'm just going to change color so it doesn't get confused with the working above it. So P1, 200,000 multiplied by V1, 1, multiplied by T2, which is 403, over T1, that was 300, multiplied by V2, that's 1.01. So this is our calculation. 200,000 multiplied by 1 multiplied by 403 over 300 times 1.01, which is 266 times 10 to the 3. So we're going to write down 2.7 times 10 to the 5 pascals. And then C says, explain why it's not possible to calculate the number of moles of gas in this question. And the answer is to do with the volume, isn't it? We don't know the volume, just the factor by which it increased. So in order to use N is equal to PV over RT, we needed the volume in meters cubed, or we can't work it out.